Hi guys. Today I'm going to give you a quick introduction to minerals. We're not going to do this entire lesson today. We'll kind of break it up into different parts, and we'll just start with what basically a mineral is. So this is the beginning of our geology unit, and we always start with minerals. And so I want to start with this basic definition that you're going to need to know. So a mineral is any naturally formed inorganic solid that has a definite crystalline structure. There's a lot to this idea of what a mineral is and what it isn't. And that's what we're really going to focus on today. Okay, so there are a list of things here, and I always have an acronym for this, which I'll show you in a second. But the first thing is a mineral has got to be a solid object. It is a solid. If it's a liquid or a gas, it's definitely not a mineral. So that's kind of identification number one, which is a pretty simple idea. It can't be a liquid or a gas, it has to be a solid. Okay, it has to be naturally occurring. Naturally occurring means it is not man-made. It's made by the earth, essentially, or by another planet. It's found in nature, and it's natural. Okay. Number three, it's inorganic. Inorganic means not living. It never was living, never was at any time alive, and it is not living, and that is called inorganic. Okay. A fixed composition. A fixed composition means it has a composition or a chemical formula made up of many compounds, or maybe just one single element that is always the same. It does not change. It's kind of like H2O is always water. That composition, if you change that composition, it's no longer water. Okay, so it's got a fixed composition. And then the last one, a crystal form, which basically means it has atoms which are arranged in a way that makes it definitely that mineral. And that one's a little bit difficult to understand because you guys haven't taken chemistry yet. But crystal form we're going to look at as we move through here. So again, solid, naturally occurring, inorganic, fixed composition, and crystal form. Those are 5 things that you should probably write down. I always remember it with this random abbreviation, SNIFC, SNIFC, just to remember what a mineral is and what it isn't. Okay, so it's got to follow all 5 of those categories. So let me show you an example of this whole crystal form idea. So this is basically the chemical structure of what a mineral called quartz. And you can see all these things kind of linking together. It's got this nice shape to it, and they're all linking together, and it's always the same. Every time you look at quartz under an electron microscope, you get this same shape to it. Okay, so it definitely has this crystal form. If it's a different crystal form, it's a different mineral. This is amorphous SiO2, which is basically a fancy word for glass. Glass is made out of the exact same elements as quartz, silicon and oxygen. But look at this weird shape. Sometimes it's got that structure like quartz, but it's all amorphous, which just means it's kind of random and irregular. It changes every time you melt that glass and reform it and recrystallize it. It's going to have a different shape. So it changes every time it turns back into a solid. Quartz, however, always has this same structure. Every time it melts and reforms and turns back into a solid again, it is going to have that shape, which defines it as being quartz. Okay, so that's what crystal form is all about. Now, cool thing is there's a lot of minerals out there. There's over 3,000 of them on Earth. Thankfully, you don't have to know all of those. Okay, on the back of your reference table, which we're going to be looking a lot at in the next few days, there are 21 common rock-forming minerals on your reference table, and these are the only ones that you're going to really need to know about. These are most common, but actually 10 of these are really the most common and make up about 90% of the Earth's crust. That's the surface of the Earth, down a few miles. So this list of 21 can really be broken down into 10, like quartz and feldspar and the micas. Those are all really, really common minerals, and you'll run across them a lot as you travel. Okay, so these are different types of minerals. Now, minerals make up pretty much everything in your daily life. You'll come across them in some way or another. Obviously, you probably know that you use graphite pretty much every day. Graphite is a mineral. I'll show you that in a second. Graphite is in your pencil. It's not lead. A lot of people like to call it pencil lead. It's actually graphite. Okay, and there's all kinds of different minerals that you'll see every day or come across every day that make up your everyday life. You don't even realize it. So it's a really important industry, obviously. Okay, now, one type of mineral that we're going to really focus in on are what are called the silicate group of minerals. So we have these 3,000 different minerals that can be really broken down into different groups based upon what they are made out of. So the silicate group are the most common minerals on the Earth's surface, and that's because they're made out of two elements, silicon and oxygen. Silicon and oxygen make up a majority of the Earth's surface, and therefore these are the most common minerals. Quartz and feldspar and mica, which I mentioned earlier, are all silicates. Okay. Now, the interesting thing about silicates is they have this crystal structure, which I was referring to earlier, known as the silicon-oxygen tetrahedron. It's a unique shape that makes up every silicate that's out there in the world. And so this is what it looks like. It kind of has this pyramid-like shape if you look three-dimensionally at this. It's got this three sides on the base, and then it's got a peak to it. So there are four oxygens, 1, 2, 3, 4, and then there's this central atom of silicon right there, and they're all linked together to make up this tetrahedron. And this is the most common shape, crystal shape, that you'll see, or crystal form that you'll see in all minerals, because the silicates make up the majority of them. So you'll see that they can get linked together in different ways. You take these structures and you put them together in different ways, and by linking them together, you're going to have an infinite number of possible ways you can basically make the structure of a mineral. And so you can kind of see these fancy names here. When I was in college, I took a class called mineralogy. I had to learn all these things and understand all these things. You guys don't need to know all this stuff. So you can see how they're kind of linked together in different ways. And this one right here, you can see it's got like this layering to it. You can see these potassium atoms right here. K is potassium. And then there's a whole bunch of tetrahedrons in the middle. And then another potassium and then more. Okay, and this is actually a unique mineral that we're going to look at in the classroom. I'll tell you what that is later on. Here's another one. Look at the density of this thing. It's all packed together with all these tetrahedrons, really, really tightly packed together. This mineral is actually quartz. It's a really, really hard, dense mineral. Here's another one, right? Just look at how they're all layered together and structured together to make these different shapes to them. Here's a cool one called talc. Talc has that layering structure as well. Again, you have a lot of different ways to put these things together, and by doing so, you essentially make different minerals. Now, there are non-silicates, which are only 4% of the Earth's crust, and they're not as abundant, obviously, but you'll come across them, especially when we do a lab. Minerals like calcite and halite and gypsum, and even the native elements like gold.
Get your own liquid gold. Go on, get! There's gold in their shells. Liquid gold.
And graphite, sulfur, copper. Those are all elements that you'll find on the Earth's surface, and they're not silicates because they're not made up of silicon and oxygen. All right, so there's a really important thing about all of this in regards to minerals. So minerals can be identified based upon the properties that they have, and we're going to be talking about the properties of minerals in a totally separate lesson and some of the things that we use to identify a mineral. But I want to answer this question, which is probably the most important thing, and the number one question you're going to get about minerals is how does a mineral get its properties? And it's all based upon the internal arrangement of its atoms. So a mineral's properties come from its arrangement of atoms. And that's what we were looking at here. These minerals are different from each other. They have the exact same chemical composition, but they have totally different structures. And that's what makes them unique. Okay, so let me just show you some examples of some minerals here on my desk. Okay, so I have a few here. And all of these are minerals, but they're all very, very different looking. They have totally different structures. They have a different color to them, different hardnesses. Some are soft, some are hard. Some rub off on your fingernail really easily, and some are really, really hard. They would scratch glass, like this one and this one. Okay, but some of these have the exact same chemical formula made out of silicon and oxygen, but they look totally different, and they have a totally different crystal structure. which makes them unique. And so that's what I'm talking about. The actual chemical structure of these things is what makes these minerals separate and different. Okay? So if you get, for an example, I love this example, and it's probably the most common one. This is diamond. Okay, you all know that. Diamond is made from carbon, only carbon. But the carbon comes together in a way that makes the structure of it extremely hard. It's the hardest substance on Earth. This is graphite. Graphite's found in your pencil. Graphite is extremely soft. Why? Because the carbon atoms come together in these sheets, in these layers, and therefore they flake off really easily on something very soft like paper. And so, even though they're made out of the exact same thing, they have totally different looks, they have totally different structures, different properties because of their structure. And so, that's a really important takeaway. Know that a mineral gets its properties from the internal arrangement of its atoms. Okay, so let's skip on down to the end of this and talk about just identifying whether something is a mineral or not a mineral. So I want you to ask these questions because I'm going to ask this question to you today. If you want to know whether it's a mineral or not, you have to decide, okay, is it a solid? That's pretty obvious. Do you find this found in nature or is it man-made? Does it have a definite crystal structure? That's a little bit hard to determine, obviously, just by looking at it. Or was it at any time living? Is it inorganic or was it organic? And so you got to ask those questions. And if any of those questions fail, then you definitely know it's not a mineral. So you're going to see a whole bunch of items today that you're going to have to categorize whether they're minerals or not minerals. So I'm going to let you do that today. And basically, you're going to see pictures like this. And I want you to tell me, is it a mineral or is it not a mineral based upon those 5 things that I mentioned earlier? Remember, SNIFC, SNIFC, solid, naturally occurring, inorganic, fixed composition, and crystal form. So just go through the list of these later, and you're going to try to determine whether these are minerals or not minerals. There's a funny picture. Okay. And that'll be your task for today. All right. And then the next lesson, what we're going to talk about are what properties do minerals have that make them unique. Okay, so we're gonna spend our next lesson on the properties of minerals. All right, so that's it for now.